The London Pneumatic Despatch Company established the world's first underground pneumatic mail railway in 1853. This system transported telegrams and letters through cast iron tubes using vacuum pressure created by steam-powered air pumps. The network addressed a critical problem. London's streets had become so congested with horse-drawn traffic that postal delivery times were unreliable and slow. The system operated on a straightforward principle. Mail was sealed inside cylindrical leather capsules measuring 8 inches in diameter and 30 inches in length. These capsules traveled through 2¼ inch diameter cast iron tubes laid beneath London's streets. Large steam engines at central stations created partial vacuums ahead of the capsules while maintaining atmospheric pressure behind them. And this pressure differential propelled the capsules through the tubes at speeds reaching 30 miles per hour. The inaugural route connected Euston Station to the General Post Office at St. Martin's-le-Grand, spanning approximately 600 yards. Engineers chose this route to demonstrate the system's capability for telegraph message delivery between railway terminals and the Central Post Office. The tube diameter was precisely calculated to allow the leather capsules to form an adequate seal against the iron walls while maintaining enough clearance to prevent jamming. Each capsule was constructed from heavy leather reinforced with brass fittings at both ends. The cylindrical design minimized friction, while the leather exterior created a flexible seal against the tube's interior. Mail sorters loaded telegrams and lightweight letters into the capsules, secured the brass end caps, and inserted them into the launch chamber. The operator then opened a valve, exposing the capsule to the vacuum pressure that pulled it into the tube network. The steam engines driving the system generated vacuum pressures of approximately 10 pounds per square inch below atmospheric pressure. This differential was sufficient to overcome friction and accelerate the capsules to operating speed within seconds. At the receiving station, the capsule entered a collection chamber where air pressure equalized, bringing it to a controlled stop. The entire journey from Euston to the General Post Office took 90 seconds. Initial operations in 1853 and 1854 proved the technical concept. The system successfully delivered 5 batches of mail per hour during peak periods. However, the limited route served only a narrow corridor of London's postal network. The company required significant capital investment to expand the system throughout the city. In 1858, the network expanded to Holborn, with a western extension completed in 1861. These additions increased the total tube length to over 2 miles. The system now connected multiple railway stations with a central sorting facility, handling approximately 30,000 messages daily. Engineers installed larger steam engines capable of maintaining vacuum pressure across the extended network. Each new station required its own receiving chamber and capsule handling equipment. The post office took direct control of the pneumatic system in 1863, recognizing its value for urgent communications. They immediately commissioned a major expansion to create a comprehensive network beneath central London. Between 1863 and 1865, contractors laid over 6 miles of additional tubes connecting 22 post offices and railway stations. The expanded network required 5 steam-powered pumping stations positioned strategically throughout the coverage area. The 1865 network could process up to 100,000 items per day at full capacity. Average delivery time between any 2 stations dropped to less than 5 minutes, compared to 45 minutes for surface couriers navigating London's crowded streets. The system proved particularly valuable during winter months when fog reduced visibility and slowed horse-drawn vehicles to walking speed. Technical specifications for the expanded network included standard tube sections measuring 10 feet in length with flanged joints sealed by India rubber gaskets. Each junction required precision engineering to ensure smooth capsule passage through intersections. The tubes were laid in brick-lined tunnels, approximately 6 feet below street level. deep enough to avoid interference with gas mains and water pipes, but shallow enough for economical excavation. Operating costs centered on coal consumption for the steam engines. Each pumping station burned approximately 4 tons of coal daily to maintain continuous vacuum pressure. The system employed 57 workers across all stations: engineers to operate the steam engines, handlers to load and unload capsules, and maintenance crews to inspect the tubes and repair leaks. From the primary technical challenge emerged from tube leaks that reduced vacuum efficiency. Even small gaps in the rubber gaskets at pipe joints allowed atmospheric pressure to equalize, reducing the pressure differential that moved the capsules. Engineers developed a systematic inspection protocol where maintenance crews pressurized sections of the tube network with smoke and observed where it escaped at street level. They then excavated those locations and replaced the failed gaskets. Capsule jamming presented another operational problem. If a capsule became stuck midway through the tube, it blocked the entire line until workers could locate and extract it. This required shutting down that section, breaking the vacuum seal, and using specialized tools to push the capsule to the nearest station. The company addressed this by implementing strict weight limits and regular capsule inspections to identify worn leather that might catch on tube irregularities. Water infiltration through joints during heavy rainfall caused temporary shutdowns. Groundwater entering the tubes created resistance that slowed capsules and eventually flooded low points in the network. Engineers installed drainage sumps at strategic locations and modified junction designs to shed water more effectively. These improvements reduced flood-related closures from an average of 8 days per year in 1867 to less than 2 days per year by 1870. The system reached peak operation in 1875, handling over 3 million items annually. At this level, the pneumatic network processed approximately 8% of London's total postal volume. Focusing on time-sensitive telegrams and urgent correspondence, the operational reliability achieved 96% on-time delivery, far exceeding surface mail performance. However, the telephone's introduction in 1876 began eroding the system's economic foundation. Telephone service eliminated the need for telegraphed messages between businesses and railway stations. As telephone networks expanded through the 1880s, urgent communication shifted to voice calls rather than written messages. Pneumatic tube traffic declined steadily after 1880. The post office maintained reduced operations through 1914, serving specialized routes where speed remained essential. During World War I, military authorities used the system for classified communications between government offices. After 1918, a declining usage made the extensive network economically unsustainable. The post office closed most routes between 1920 and 1930, though one line between Paddington and the Western District Office operated until 1963. The final section shut down in 1984 when the post office demolished the Paddington sorting facility. At that point, the pneumatic tube had served London for 131 years. Several tube sections remain beneath London streets, sealed and abandoned. The lesson transcends pneumatic mail delivery. When infrastructure is optimized for a specific communication technology, changes in that technology can render the entire system obsolete. The London pneumatic network was engineered perfectly for telegram distribution in an era before telephones. Its technical success could not overcome the economic reality that voice communication eliminated the need for rapid physical message transport.